Hi there, General Physics. Mrs. Grady here. Let's do some practice with the force of gravity and converting mass to gravitational force, and then converting gravitational force back to mass. All right, so as you can see, I'm going to have some writing down here on the bottom. Put a little cloth down here so I don't hit a button with my wrist. Unfortunately, like inadvertently. Okay, so the main formula that we need to know is this one. Fg equals mass times little g. Now, a couple things. Fg, as we know, is the force of gravity, but there's another word for it. We also call this an object's weight. So realize that if you were asked for the weight, you were being asked for the force of gravity in newtons, not in pounds. All right, we don't use pounds. All right, mass, that is always going to be in kilograms. If it is not already in kilograms, you will need to convert it by dividing by 1,000, okay, because there are 1,000 grams per kilogram. Last but not least, little g. Little g is what's known as the gravitational. It's often referred to as the acceleration due to gravity. We have two different sets of units we can use. What we found in the lab was newtons per kilogram, but also understand that reduces. The newton is actually a combined unit. So if you reduce that down, it could also be meters per second squared. And that is more likely what you're about to see in all of your practice stuff. Okay, so just keep in mind that's not wrong. It's just different. Okay, so here's a classic. All right, I've got a calculator. Good thing. Can't do my work without a calculator. Here's a classic way that a question gets phrased. How much does this, whatever your mass is, weigh? Okay, now first of all, this term definitely tells me right away I have Fg involved. I'm already given my value in kilograms, but let's say instead I was told it's 5,000 grams, I would need to convert that, right? And that would actually only be 5 kilograms. So 50,000 grams. All right, now, if I want to figure out how much the dog weighs, I'm going to need to take that 50 kilogram mass, multiply it by 9.81. It does not matter which set of units you use, okay? Your unit in the end is going to be the Newton. And so when I take 50, yes, I know my batteries are low. The calculator always likes to tell me things, and I like to ignore the calculator. All right, so 490.5. What's the unit for this? It's the Newton. Okay, force is measured in newtons. So you can kind of see here what a Newton is made out of. It's made out of a kilogram times a meter divided by a second squared. Aren't you glad they reduced that to a Newton, right? But it also is handy to know. That's why I can take this, and if I substituted this in for it and did some algebra and some, canceling and such, I would get this. That's how I can say they mean the same thing. That's how that works. All right, let's go in the opposite direction. Shoot, I'm trying to even come up with something remotely reasonable. That many newtons. Okay, so again, let's look for some visual clues here. All right, first of all, they give you the term weighs. That's referring to a force. Weight always refers to a force. In this case, of course, it is Fg. Notice the unit is already in newtons. That's going to give you a hint as well. I always like to use units to give me hints when I'm not sure what I'm looking at. What is the mass of your car? Okay, that one's pretty obvious. I don't know what else I can really say about that. All right, but there's my formula. I want to know the mass of my car. So if I want to know the mass, I'm quite simply going to divide. Force of gravity divided by little g. So my force of gravity, 250,000 newtons, and I'm going to divide that by 9.81 newtons per kilogram. See, I'll do it the other way this time, right? And that will show you these will end up crossing out, and then you'll have 1 over kilograms. When you flip it around for fractions, you end up with kilograms as your, yes, I know my batteries are low. Again, it thinks I don't remember, probably because I never actually do anything about it. All right, so if I take my 250,000 newtons, basically I'm dividing it by 10. I'm lopping off one of those zeros, but to be fancy, let's do the number that they give me in the calculator. Right, 25,484 kilograms. Yeah, maybe that's pretty good. I don't really know what a car weighs or what its mass is. I just made up a big old number. All right, but it gives you an idea of how you're going to work back and forth and some of the clues that you are going to need in order to know what it is you're solving for. I strongly suggest when you're doing WebAssign, look at the units you're given, look at the units next to the box, and that will help you decide which way you are going to go. See me with questions. You need to know this formula. You need to know little g. All right, I'll talk to you soon. Bye, guys.